Hello everyone, and welcome back to this tutorial series on Unreal Engine Audio. In the last tutorials, we went over the basics of blueprints. In this tutorial, we will be taking you more in depth into the event graph as we add more functionality to your blueprints. To start this off, we are back at shortcut 9, and we're just going to open up the content drawer and open up the blueprint basics to get started. Again, if you come up to this screen, just click Open Full Blueprint Editor in order to edit this blueprint. The main functionality that we covered in the last tutorial had to do with overlap triggering. While having these events trigger sounds is quite useful, sometimes we only want things to happen if certain conditions are met, such as dialogue playing or if you've collected a certain item. While having these events trigger sounds is quite useful, sometimes we only want things to happen if certain conditions are met, such as dialogue playing only if you have collected a certain item. This is where conditionals come into play. To talk about conditionals, first thing we need to cover is the idea of a Boolean. A Boolean is a type of variable that can only be stored as a true or false value, 0 for false, 1 for true. It can't be a number, a word, or anything else. It can only be true or false. So what we're going to do first is we're going to create a new variable like we covered in previous tutorials. We're going to name this play sound. We press enter. As you can see, the default value is a Boolean. This is exactly what we want for this scenario, but if you wanted to change it, you can either click here, choose your value, or click up here in the details panel. Then we want to make it public, so then we can change that when we're in the level. For this case, we want to use this variable to set whether or not a sound will play when we overlap with our trigger. The way that we do this is by using the branch node. So if we right click in here and type branch, we can see the branch node pop up. So the way that we do this is we connect our event actor begin overlap up to the branch, and then out of true, we connect up our play sound 2D, which in this case I'm going to use the village wind. And then you'll notice that there's this condition right here. What you can do with this is the value itself is a Boolean, and so if you have this checked, it means that the condition is currently set to true as a default. So if we were to just play this, it would go through the true, and then it would play the sound. But if we were to have this connected to the false, it would not play the sound in this case. The way that we can utilize our Booleans is by dragging our variable into the level. If you hold Control, it will get that value. We can connect that up to our branch. You'll notice over here within the default value, this is currently set to false. So if we were to play this right now, as soon as the overlap is triggered, it will play the false execution node instead of the true, and a sound will not play. Let's demonstrate that in the level. As you can see, the sound is not playing. But if we were to go in here, and since we have it public, we can see under our default settings that there's the option to check play sound. We check that, it changes it to true, and now, if we press play, we can walk up to the stone, and the sound will start playing. If you for some reason want to have the value be the opposite of what you currently have, for example, if you wanted to have something play if sound is not true, you can either connect your node to the false side, or you can use a not Boolean operator. So that means that when this is true, the actual condition will be put as false because it is saying this condition will be true when it is not true. It's a little bit confusing, but this is just one of the ways to inverse your Boolean rather than constantly changing it within your level. Creating a Boolean variable is not the only way to get a Boolean result. Other ways that you can create Booleans are through different equivalent operators. Some of the examples for these are the equals, greater than, less than, or not equal to. Basically what that means is that it will check whatever two values you have going in. In this case, that would be float values. It will see if they're equal, greater than, less than, or not equal, and whether or not that condition is true will set the condition for this branch. On the topic of nodes that control when things happen, we have the flip-flop node, the do once node, and the delay node. The flip-flop node allows you to swap between two events. A good example of this would be having the ambient audio change when you walk through a door. You would want one sound to start playing when you walk in, while you would want the opposite sound to start playing when you walk out. For demonstration, we will instead be swapping between a sound playing and fading out that sound. The way that we'll do that is using the node fade out. And if you'll notice it's not appearing here, and that is because it is currently set to context sensitive. If we uncheck that, we now have the option under audio for fade out. This is a node that allows you to fade out a sound over a certain amount of time using the fade out duration, down to a certain level, which in this case for us will be 0, and you can also control the curve that this follows as it is fading out. When it comes to nodes like the fade out node, it is very important to use the spawn sound instead of the play sound node. The reason for this is the spawn sound actually gives you an actor that you can reference by other nodes in your blueprint, while the play sound will not. So let's grab a spawn sound 2D. We're going to use our classic sound, Village Wind. Then what we're going to do is we're going to connect our event actor begin overlap, connect our A execution, which is what happens first as soon as it's triggered, which will play the spawn sound 2D. And then as soon as we overlap with it again, we will fade out the sound. Now you want to make sure that the spawn sound return value is put into the target. Now if you'll notice, this is currently not being compatible because if you look at the top, it says target is synth component. This is what can happen when you don't utilize context sensitive within the all possible actions. By doing that, it doesn't know what type of component it's going to be fading out, so it just defaults to whatever one it thinks is appropriate. If we drag off the return value, we can type in fade out, click on that right here, which now it says target is audio component instead of synth component. So if we click on that, you can see that it is now connected up perfectly and the compatibility issue is resolved. However, we want to disconnect these and have B be connected to our fade out. If we run this within our level, so as soon as we walk in, as you can see, the sound has started playing. And then when we overlap with it again, there you go, the sound stops. The delay node works exactly like you think it would. Basically, it waits a certain duration of seconds, and then it plays the sound. This can be useful if you need to sync up timing with a sound, or just have a sound come slightly delayed after something occurs. Finally, the do once node allows something to only occur once. Remember back to that issue we had with event tick? Well, if we use do once instead, this will allow us to only have this occur one time. So if we connect up this event tick, put it through to the completed to play our sound, then we go to the level. And as you can see, it just plays it once instead of playing them every single tick within the editor. As you can see within the do once, there is an input for reset. If an event were to trigger this, the do once would be allowed to fire again even if it had already run once. This can be triggered by some other event in the blueprint, but a useful way to do it, especially for audio, is by binding it to when the audio finishes playing. We will again be using the spawn sound node to have a reference that we can use again in the blueprint. By dragging off the return value, we can get a reference to the audio component. The node we then use to check when audio is finished is called bind event on audio finished. There it is. If we link these up, what that means is that it is able to check the sound file that we're using, and as soon as the audio finishes, it will then allow it to be played once more. The way that we do that is by dragging off this event, and we can either add a custom event, or we could add an event dispatcher, which we might be going over in a later tutorial. But for now, let's just do custom event. We're going to name this reset for obvious reasons. Now what this means is that as soon as our audio is finished, it's going to trigger this custom event, which we will call again over here, which will then reset the do once node. To demonstrate this, let's connect it up to the event actor begin overlap, compile and save. So if we press play, we can walk up and trigger this sound. But then if we were to walk over it again while the do once is still active, nothing will happen. I'm going to skip ahead in this video for once the audio is done playing, and then I will show you that we are able to walk over it once more and trigger the sound. Alright, the audio has finished, and so then if we walk over this again, you'll see that it has in fact reset. This can be a very useful tool within your level to be able to bind events on audio finished, so that you don't have your actors and audio overlapping with each other within your level. This next section of blueprints is going to be quite helpful when dealing with different actors in your level. When you start to work with placing sounds in different locations, you need to know where your different actors are within the level. The most important actor to know about when it comes to sound design is the player. There are two ways to access the information about the player/character that you are going to be working with. You have the getPlayerCharacter and you have the getPlayerPawn. The difference between these two goes back to classes that we discussed in the Blueprint Fundamentals tutorial. Every class has a parent class that it derives its functionality from. Both of these are children of the actor class. Pawn is an actor in the game that can be possessed and controlled by an outside source. This could be by an AI or by the player. But a character is a pawn that is specifically designed to be controlled by a user input, so it is a child of the pawn class as well as the actor class. The node that I default to for use is the getPlayerCharacter, but if you ever find that this doesn't work, change it to getPlayerPawn. This will cover a wider scope of possibilities. The way that we are going to be demonstrating these nodes is by visualizing where a sound is being played. This can be a useful trick when debugging your level because it allows you to visualize where a sound is being played. In order to do this, we will be using the node spawnActor from class. If we take this event actor_begin overlap and connect it to our spawnSound2D, we can get our player character, and then get actor location, take our return value, put that into the transform, it does an automatic conversion, and then we're going to be using the class visualizer, or actually the POS test visualizer, and then we are going to connect the end of the spawn node to the spawn actor POS. What this means is that as soon as we overlap with the actor, it will play the sound and then spawn a visualization at the location of our player. Something that I realized is that we'll want to use the spawn sound at location instead. The reason for this is so that we can spawn the sound at the same location as our POS test visualizer. So if we compile and save, let's test this out in the level. So as soon as we walk up and overlap, you can tell that the sound is spawned right there. And so if we were to turn, the visual matches exactly where the sound is being spawned. And as you can see, when I walked through it a second time, it spawned a second actor. So if I were to come in over here, it would spawn right there. This can be a useful trick to use within your level. Now, we've been able to spawn the sound at the location of the blueprint itself in the last tutorial, as well as the location of our character. But what if you wanted to spawn the sound at a location of a different actor? You could try to estimate the location of the actor, but that could be very tedious and inaccurate. And what if you move your actor around the level? Luckily, there is a much easier method available. First, we're going to need to create a new variable within our blueprint. So if we click plus up here, we can title this actor. And then what we're going to do is we're going to change the variable type of this to actor. Go down to object types, get an object reference, and there we go. Now what this means is we have a variable that stores the type actor. And so what we can do is if we make this public, we can go into the level and select a different actor that we want to access its location. So let's head back into the level. The actor that I'm going to want to spawn this at is going to be this SM Grass Patch Variation 1, as it'll be easy to visualize. So if I set that right over here, then we now have an actor where we want to spawn the sound. So if we click on our blueprint, we can see that we now have this actor in the default window since we have it set to public. What we want to do is we want to set the actor type within the level so that it knows where to spawn the sound. We can either do that by clicking here and typing in the name, or we can click on this dropper and just select the actor that we want, which in this case is that SM Grass Patch. Now it knows to reference that actor when we are using it in the blueprint. So if we hold Control and drag our actor variable into the level, we'll get its reference. We drag off and put this into the get actor location. Now it will spawn the sound and the visualizer at the location of that actor. Let's demonstrate. So right now there are no sounds playing, but if I walk up, you can see that it spawns both of those at the actor's location. The last thing that we'll be covering in this tutorial are the mathematic functions that you have within the engine. The beauty of the Unreal Engine is that it already has virtually every mathematical function you could want for basic functionality. In order to show you, let's right-click in the level. Let's just type in math. As you can see, there are lots of different options that we can use. Some of the most basic ones that we'll be using, though, are the plus, which is add, the minus, which is subtract, multiply, which is star, and divide, which is backward slash. A concept that is important to know about that we'll be using several times throughout the engine is the idea of a vector. Now, little did you know, but we have actually already been using vectors within our blueprint. As you can see, a location is made up of 3 values, an x, a y, and a z, as you would expect. When you have something that is more than just one value, that is known as a vector, because it has both a magnitude and a direction. So if we hover over this, you can see that the location is in fact a vector value since it has more than one value. Some of the most important functions we'll be using is makeVector, which takes in 3 single value floats and turns that into a value that we can use here. And then there is breakingVector, which is if we were to take one of these and break vector, you can see that now we can access each of the individual values from that location vector that is already created. The last 2 nodes we'll be covering in this tutorial have to do with random nodes and ranges. So if we type in random float in range, what that means is you can set a minimum value and a maximum value, and every time that it asks for this value, say we wanted to enter it into something else, it will randomly pick a number between your minimum and maximum numbers. This can be useful for randomization for location, volume, anything like that, and we will be using this several times throughout these tutorials. Then finally, we have map range clamped. This is especially useful when we start working with volume. What this means is that you have an in range and an out range. So let's say you have a value within your level where you're using a slider or something, and you have values ranging from 0 up to 10,000. Now, those values are not very useful for volume when we're usually working in the range of 0 to 1, but what you can do is you could set the in range to 0, and then the in range B to 10,000, and then set your out range 0 to 1. What this means is that it will take your range from 0 to 1,000 and map that to the range 0 to 1. So if I were to get the value 5,000 from the in range, you would get a value of 0.5 for your out range. This really helps narrow things down and make these numbers usable for things with audio such as volume and pitch. A last little tip that I want to leave you with is when working with either sound cues, blueprints, or anything involving an event graph, it can sometimes get a little bit messy, kind of like how you see here. A way that you can fix this is if you double-click on a point on the connection, it gives you a node that you can then adjust. This can help organize things or help make items move around other nodes or branch off. A thing to note, though, is that if you double-click and create one of these, you can only move it around when it is highlighted like this. If you were to click, you can actually drag off and place a new node to create multiple locations. But if you want to move it, you need to highlight it and then adjust that around as you please. What we have covered in this tutorial are the many different ways to add audio functionality to your games and blueprints. We covered conditionals, actor locations, as well as mathematics. We'll be using this information later on in the course, so make sure you at least have a baseline understanding of these techniques, as well as watching the other tutorials linked with this series. If you'd like to see more in-depth techniques on making interactive audio in blueprints, be sure to check out the Dynamic Audio series by Richard Stevens and Dave Raybould on the Epic Games Learning page. And as always, I'll see you in the next tutorial.